Ever wonder how AI really deciphers the world around us? Not just text, but sounds, like recognizing a dog's bark, a baby's cry, or even the subtle shift in a voice that signals happiness or sadness. Today, we're unpacking a revolutionary study called AudioLens that's rewriting the rules of how large audio language models, LALMs, process auditory information. Spoiler, it's not just about hearing. It's about understanding in ways we're only beginning to grasp. Let's start with the basics. LALMs are AI systems trained on both text and audio, enabling them to listen and read simultaneously. Think of them as supercharged assistants that can transcribe a podcast, detect emotions in a voice, or even identify a specific animal in a soundscape. But here's the catch. While we've mapped how these models handle text, their auditory processing has remained a black box. That's where AudioLens steps in, using a technique called Logit Lens to peer into the model's thought process layer by layer. Imagine a magnifying glass for AI. Logit Lens lets researchers track how LALMs extract clues from audio, like determining a speaker's gender, emotional tone, or even the presence of a cat meowing in the background. Here's what they found. The deeper the model goes, the more it loses some of this information. For instance, if a model struggles to detect happiness in a voice early on, those emotional cues vanish in later layers. But if it gets it right initially, those clues stick around, shaping the model's final output. It's like a relay race. The first runner, early layers, must pass the baton clues about tone or content clearly. If they fumble, the whole team, the model stumbles. But here's the twist. LALMs don't just rely on their internal memory. They actively query the audio input, like a detective cross-referencing evidence. This explains why they sometimes struggle with complex tasks. They're not always connecting the dots between clues. The study revealed a critical insight. Resolving auditory attributes early improves accuracy. If a model identifies, this is a dog, in the first layers, it has more time to refine that info as it processes deeper. Researchers even tested a fix. They injected early clues into deeper layers, boosting accuracy by 16.3% without retraining the model. It's a game changer for applications like voice assistants or medical diagnostics, where precision matters. But this isn't just about one study. Researchers are now exploring how models think deeper. Techniques like back attention let AI revisit clues, while knowledge neurons reveal how models store facts. Meanwhile, fairness studies show how biases in training data can skew results, and new methods are tackling audio-specific errors, like teaching AI to distinguish a whisper from a shout. This isn't just about fixing AI, it's about understanding how these systems evolve. From decoding auditory clues to refining their own reasoning, we're witnessing a new era where AI isn't just reactive but reflective. The next time you interact with a voice assistant or stream a podcast, remember, behind the scenes, researchers are unraveling the mysteries of how these models hear and learn. The future of AI isn't just about power, it's about precision, fairness, and the relentless pursuit of understanding. Stay curious, because the next breakthrough could be just a paper away.